Hello and welcome back to Activity 5. Today we're going to work on Lesson 5.2, which is Special Products of Binomials. So in 5.1 we learned how to multiply binomials and we used what was called the FOIL process or distributive property. We also used a box method. Well, today we're going to look at two very special cases of binomials. And so our learning targets are 1, multiply binomials, and 2, find special products of binomials. So our first special case is going to be on this first page here, and we're going to just kind of try to discover it as we work through the problems. So determine each product. So I'm going to go ahead and do my multiply. So I'll do first times the first, so x times x is x squared. And then if I do the outers, x times -1, that is negative x. And I do the inners, 1 times x, that's going to be x. And last times last is 1 times -1, -1. Now if you remember, most of the time the middle terms will get to be combined, and if you notice here, you get 0. Negative x plus x is 0x. And so we end up with an answer of x squared minus 1. And so this is a case where a binomial product actually gave us another binomial instead of a trinomial. Okay, so we're going to try another one. So I'm not going to draw the arrows to save a little space, but we'll still talk through it. So let's try x times x. We're going to get x squared. And then my outer is negative 4x. My inner is positive 4x. My last, 4 times -4, I get negative 16. So it happened again. Okay, so let's examine why this keeps happening. Okay, so let's look at x squared minus 16 as a final answer and see why that middle term is dropping out. So if we look at the binomials in part A, we were multiplying x plus 1 times x minus 1. And in part B, we were multiplying x plus 4 and x minus 4. Okay. Now in part C, do we think that's going to happen again? I see x minus 7 and x plus 7. Let's see if it's going to happen again. So let's take x times x, we get x squared. Our outers is x times 7, so plus 7x. The inners, negative 7 times x, or negative 7x. And our last, negative 7 times 7, negative 49. So again, the middle terms drop out, and we get x squared minus 49. Okay, so as we're looking at these answers, we should hopefully notice something in common. They're all x squared. They're all different. I see minuses in each one. And look at this, the last term. We've got a 1, a 16, and a 49. Hopefully you recognize all of those as being perfect squares. All right, well, one more looks a little different because it's not just x and x, it's actually 2x and 2x. So now I'm looking at 2x minus 3, and I'm looking at 2x plus 3. So 2x times 2x is going to give me 4x squared. Then you do the outers, 2x times 3, that's positive 6x. When you do the inners, negative 3 times 2x, that's negative 6x. It happened again. Negative 3 times 3 is negative 9. And those middle terms cancel. And we get 4x squared minus 9. So we didn't get a 1x squared this time, but we got a 4x squared. So notice we have a perfect square, again, as a coefficient for x squared, and a perfect square for the last term, which is 9. And notice they're all minus. Okay, so we have a name for this. We call this the difference of two squares. Okay, so we should notice some patterns. We talked about them quite a bit. So first of all, we see that the quantities are what we call conjugates. Okay, so conjugates are quantities like a plus b times a minus b. So the two quantities only differ by their sign in the middle. Okay, and when you have that, when you try to multiply conjugates like a plus b and a minus b, the middle term, okay, of the product is always going to be 0. Okay, and the result is we always end up getting a squared minus b squared. Okay, so 2x times 2x gave us 4x squared, and 3 times 3 gave us 9. Well, it was negative 3 times 3, so it gave us negative 9. So we call that a difference of two squares. And so if we look at the box on the side here, it says a binomial in the form of a squared minus b squared, like all our answers we just got, is known as the difference of two squares. So anytime you have binomials in the form of a plus b and a minus b, a special pattern called a difference of two squares occurs. And we can use these patterns from problems 1 and 2, and we can explain how to find the product of a plus b and a minus b. So to do a plus b and a minus b, you can always do all 4 steps of FOIL, okay, with all binomials. It's a good habit to always do all 4 steps of FOIL. But when you notice you have conjugates, when you notice you have a plus b and a minus b, it's a special product. And so really all you have to do is a times a to get a squared, and b times b to get, well, b times negative b to get negative b squared. And so we get a squared minus b squared. So we end up with a binomial, okay? And that's our special product pattern. So when we have a squared minus b squared, it's always going to come from a plus b and a minus b in that product. So when you recognize those, they're kind of like a shortcut. Okay, we have one more special product, and we're going to discover that as well. I don't know that I'll do all of these problems, but you know, maybe we'll do the B column because we have some space over there. So if we look at, let's look at part B. So what we have here are quantities that have been squared. So what you have to remember is that a quantity being squared is actually that quantity twice. So just like if you saw 3 squared, you would write 3 times 3. Or if you saw x squared, you could write x times x. If you have a quantity squared, you must write it twice. Okay, so it's 4 plus y times 4 plus y. Okay, and then you could do all 4 steps of FOIL and maybe we'll see a pattern. Okay, so it is the same binomial being multiplied by itself, and that's why it's allowed to be written as a binomial squared. But when we do our steps of FOIL, 4 times 4 is 16. And then notice that your outers and your inners are identical. 4y plus 4y. In the middle, you're getting 8y. Okay, and then last times the last is y times y, which is y squared. Okay, so we've got the first term squared. 4 squared is 16. Okay, we got the last term squared. Y squared is y squared. But then in the middle, we have an 8y. So where did that come from? And let's think about that. Let's try another one. Maybe we'll come over here and do part C. So we have some room on this side now. So this time we have x plus 7 quantity squared, which means I want to multiply x plus 7 times itself. Okay, so sometimes when you see these quantities squared, you want to think write it twice. It means there's 2 quantities. So first times the first is x squared. Again, your outers and your inners are identical. 7x plus 7x, 14x. And then your last times your last is 49. So I see the first term squared, x, gave me x squared. The 7, the last term squared, gave me 49. But the middle came from where? Over here again, the middle came from where? Well, hopefully you notice that if you take the product of 4 times y and you multiply it by 2, you get 8y. If we take the product of x times 7, you get 7x, times 2 is 14x. So 2 is going to play a role here. So let's try another one. How about we work on F? So in F, we have 4 minus x times itself. First times the first is 16. Okay, so that's the 4 squared. And then when we do our outers plus our inners, so we do the negative 4x and another negative 4x. It's always going to be twice that product. So that's going to be 2 times negative 4x, which is negative 8x. And then negative x times negative x is positive x squared. So the 4 squared gave us the 16. the x squared gave us the x squared, and then 4 times negative 1x is negative 4x, but times 2 is negative 8x. So you're always going to double the product of a and b, and that will always get you your middle term. Okay. All right, let's do h, and then we'll write out our rules. So for h, we have 2x minus 3 times 2x minus 3. So 2x times 2x is 4x squared. That's 2x squared. Okay. Then we have the outers, which is negative 6x plus another negative 6x, negative 12x. That's 2x times negative 3 times 2. And then negative 3 times negative 3 is positive 9. So hopefully you see these patterns. So I noticed that each product is, okay, variable term squared, twice the variable term times the number, and then the number squared. So you got the variable squared plus 2 times the variable times the number plus the number squared. Okay, every time. So in other words, it'll be a little easier to see, I think, with the formulas. If you take a look at the square of a binomial. So there's 2 types of expressions you could see. You could see a plus b quantity squared. And that would be one like we saw in letter C or letter B, where we had x plus 7 quantity squared. To expand that, you could write it twice in FOIL. You can always write it twice in FOIL to be safe. But if you know the shortcut, it might go a little faster. It's just going to be the first term squared, which is a squared. It's going to be the last term squared, which is b squared. But your middle is going to be twice the product of the a and the b, those 2 terms. If it's a minus b squared, again, you can write out a minus b times a minus b. You could FOIL, combine like terms, you're good. Or first term squared, last term squared, but the middle this time is going to come from a 1a times a negative b. So it's actually going to be negative 2ab in the middle. Okay, but your last term should always be positive because b times b is always going to be positive if they're the same. Whether they're both negative, they multiply to positive, or they're both positive, they'll multiply to positive. So we call this the square of a binomial, and you can use the pattern or always write it twice. A plus b times a plus b is a squared plus ab plus ab, because they're going to be the same, ab and ab plus b squared. You know, or if you have both of them, a minus b, same thing. Write it twice in FOIL. A times a squared. Outers is negative ab. Inners is also negative ab, which is better than saying ba. We just try to keep it the same. And then negative b times negative b, still positive b squared. Okay, so if you recognize the patterns, great. You might not have to write it twice in FOIL. But what you don't want to do is just square a and square b and think you're done. So there is no distributive property happening here. You can't just distribute this to a and b because you've missed out on your middle term. Your middle term will be gone and your expressions will be wrong. So don't try to distribute this square into a quantity. It doesn't work that way. Okay? So I think at this point, you're going to be on to your practice problems. All right, so you've got 10 through 18, and I would like you to, FOIL, or if you know the pattern, you don't need to FOIL, you can just write out your answers. Okay, check your answers online, and let me know tomorrow if you have any questions.